Hi, so today we will be covering data flow diagram. So let us look at the diagrams first. Here is a level 0 DFT for safe home security. And here we have got another diagram. This is level 1 DFT for safe home security function. See how the complexity, the details of the diagram increases. And this is level 2 DFT. The information further increases in level 2 DFT. So let us start with the text. The DFT takes an input process output view of a system. That is, data objects flow into the software are transformed by processing elements and resultant data objects flow out of the software. Data objects are represented by labeled arrows and transformations are represented by circles, also known as bubbles. The DFT is presented in hierarchical fashion. That is, first data flow model, sometimes called a level 0 DFT or context diagram, represents the system as a whole. Subsequent data flow diagrams define the context diagram, providing increasing detail with each subsequent level. We could see that in the level 0 DFT, level 1 DFT, and level 2 DFT. Creating a data flow model. The data flow diagram enables you to develop models of the information domain and functional domain. As the DFT is refined into greater levels of detail, you perform an implicit functional decomposition of the system. At the same time, the DFT refinement results in the corresponding refinement of data as it flows through the process that embody the application. A few simple guidelines can aid immeasurably during the derivation of a data flow diagram. 1. The level 0 data flow diagram should depict the software system as a single bubble. 2. Primary input and output should be carefully noted. 3. Refinement should begin by isolating candidate process, data objects and data stores to be represented at the next level. 4. All arrows and bubbles should be labeled with meaningful names. 5. Information flow continuity must be maintained from level to level. And 6. One bubble at a time should be refined. There is a natural tendency to overcomplicate the data flow diagram. This occurs when you attempt to show too much detail too early or represent procedural aspects of the software in view of information flow. To illustrate the use of DFT and related notation, we again consider the safe home security function. A level 0 DFT for the security function is shown in figure. The primary external entities boxes produce information for use by the system and consume information generated by the system. The labeled arrows represent data objects or data object hierarchies. For example, user commands and data encompasses all configuration commands, all activation deactivation commands, all miscellaneous interactions, and all data that are entered to qualify or expand a command. The level 0 DFT must not be expanded into a level 1 data flow model, but how do we proceed? Following an approach suggested, you should apply a grammatical parse. Referring to grammatical parse, verbs and safe home processes can be represented as bubble in the subsequent DFT. Nouns are either external entities, data, or control objects, or data stores. From the discussion in chapter 6, recall that nouns and verbs can be associated with one another. Sensor is assigned a number and type, therefore number and type are attributes of the data object sensor. Therefore, by performing a grammatical parse on the processing narrative for a bubble at any DFT level, you can generate much useful information about how to proceed with the refinement to the next level. Using this information, a level 1 DFT is shown in figure. This is the level 1 DFT. The context level process shown in figure has been expanded into 6 processes derived from an examination of the grammatical parse. Similarly, the information flow between processes at level 1 has been defined from the parse. In addition, information flow continuity is maintained between level 0 and 1. The processes represented at DFT level 1 can be further refined into lower levels. For example, the process monitor sensors can be refined into a level 2 DFT as shown in figure. Once again, that information flow continuity has been maintained between levels. The refinement of DFT continues until each bubble performs a simple function, that is, until the process represented by the bubble performs a function that could be easily implemented as a program component. In Chapter 8, discuss a concept called cohesion that can be used to assist the processing focus of a given function. For now, we strive to refine DFTs until each bubble is single-minded. Thank you.